Yeah, camps on everyone. Let's start off. Last class we have finished with EMI. Today we will start off with alternating current. Start off. So what is alternating current? So if the direction of the current changes periodically, and magnitude need not be constant. So if you take a sine function, so the thing is the value rate should keep on changing direction, means the current will keep going front, back, and so on. This is also an AC current. This is also an AC current. So the main thing is the magnitude can change. If you see in this scenario, the third case, I kept the magnitude same. In minus I, the magnitude is same, but the direction is changing. So the thing is the function should keep changing periodically the sign. So current should keep flowing in the opposite direction. Front and back, front and back. So such a thing is called an AC current. So that is how we define it. So but the function is not periodic, then it is not AC. Again, when you say periodic, remember the meaning is it should repeat the same value in the same way after a certain time interval. You should get the same magnitude, kind of like a periodic motion. So if you have something of this sort, if you see this is not periodic. So it's not AC. It's changing direction, but it is not changing periodically. Play with this. Next thing, what is DC then? So the DC, the direction of the current does not change. The current keeps flowing only in one direction. And magnitude need not be constant. So generally, whenever people think about DC, right, they think about a constant voltage or a constant current, which is not necessary. So if you take a mod sine function, this is also DC. This is also DC. This is also DC. So generally, we think the constant in DC, not necessary. As long as you don't change the direction and you keep a magnitude can change, these all are DC currents only. The general misconception is that DC matlab people think it should be constant, not necessary. The current should not keep changing direction. Now, if you look at AC and DC, right? AC, we have seen in the last chapter, transformers. AC is pretty efficient for power transmission. If you want to send energy from one point to another point, sending in AC current form is more efficient because of transformers. You can step up and step down. AC also has its own drawbacks. AC cannot be used for electrolysis. Because if you put an AC, the anode and the cathode will keep shifting periodically, so there will be no deposits. AC also has a small another issue. AC current actually flows on the surface of the wire. It doesn't flow inside the wire. This is called skin effect. So that means if you just take one thick wire, and the current becomes almost zero at the center, and this is how the current flows. So that means making one single wire is a pretty bad idea for AC. So that is a reason. Next time, observe if you cut any wire and see, you'll not find a single wire, you'll find multiple strands. Ever observed that? When you take the wire, it has multiple strands like this. Because if you take multiple wires, you can increase the surface area. It kind of looks like this. That's a bit about AC and DC definition. Now, the thing is, we are so used to using these DC batteries and everything that we studied. People are kind of obsessed with the DC only. Even though you're getting AC for transmission and all, people would prefer to study something which is constant. Simple, na? If I come and ask you what is the voltage in the house, and if I tell you it is 220 root 2 sine omega t, people will look at you like, what the hell are you talking? The thing is that people are dumb, getting it. So you need simple things. So people wanted, like, if you simply come and say 220 volt, people understand. People are happy. Oh, okay, 220. So it is always like that. See, a single person can be intelligent, but a crowd is always dumb. That is how it is. So you should never try to preach the crowd. They'll kill you. Anyway, so that is one thing. Any simple thing, think about it. Copernicus, Galileo, all these people, when they talked about Copernicus, if you see, he said Earth is going around the sun. What did they do? They imprisoned him. They threw stones on him. Right. So that way. But when Newton came and said universal law of gravitation and all that stuff, people were happy. Now, what's the difference? Newton, more than a scientist, he knows how to do presentation properly. He's a good marketing guy. The difference is this. All this Galileo, Copernicus, and all people who came before Newton, they used to come out outright and used to say, God is not there. Right? All this, Earth is the center of the universe and all this is bullshit. What's actually happening was, all the world works based on science. Newton was smart. You know what he did? Newton was actually one of the member in a church. He was a very high position member. This guy, once he got all the theories and everything done, he went to the church straight, right? He kept all the people there. He wrote everything on the board and he explained them. You know what? He said, this is the language of God. And here I am trying to figure out how God works in mysterious ways using science. Did you see how he phrased the words? He didn't say God is not there. He's saying God is there and this is the language of God. And I'm trying to prove God using science. And people were so happy. I said, yeah, this guy is supporting God. Then they're like, Newton, you do whatever you want, publish whatever you want. So there, keep this in mind. So just because you're right doesn't mean you should tell the people. If you go and tell a blind person you're blind, he feels offended. You should call them visually handicapped. It should sound good. Right? If you go and call someone fat person, they'll get offended. You should say, is a healthy boy. That way. So anyways, so that is a little about it. So we want to study everything in terms of DC. So people came up with something called RMS value. So this we studied in KTG. RMS is root mean square. So RMS value is a DC equivalent which produces same amount of heat. So we need to bring some kind of similarity. So we have taken heat. Which produce the same heat as an AC current or AC source in one time period. So RMS value, end of the day, it is about heat produced in one time cycle. That means, let's say if you have a resistor R, and let's say we have a voltage which is changing with time periodically. So now you are saying, I want to replace this time varying voltage or whatever with a constant DC source. And I like to call it VRMS. And you're saying in one time period, the heat is same. So what is the heat produced in a resistor? Heat produced in a resistor is power into time integral V square by R dt, because V is changing with time for 0 to t. Agreed? Power into dt, and power is V square by R. Now for a constant DC battery, what is the power? Vrms square by R integral dt from 0 to t, because Vrms is constant, it comes out of the integral. And now you're telling me these two are equal. That means integral V square by R dt from 0 to t is equal to Vrms square by R integral dt 0 to t. There. So from here we get Vrms is equal to V square dt integral 0 to t by integral 0 to t. If you guys remember, in KTG we had a similar formula like that, remember? Integral V square dn by integral dn. RMS velocity of molecules, the general formula. We did some weird questions also on that. There, this was the formula for VRMS, if you remember. And we did some questions of this sort, different functions and all. There, this was the continuous distribution. And similarly, I can do the same thing for IRMS. That will be integral I square dt 0 to t by integral dt 0 to t. There, it becomes more of a max problem. Similarly, if I ask you to find V average, that will be integral V dt by integral dt. I average will be integral I dt by dt. There, you can note it down in case you don't remember this stuff. So if someone asks you for VRMS, this is where you come. And remember, the whole end of the day, the story is you're making the heats equal in one time period. Clear with this? Go ahead. So if you want VRMS, use V square, IRMS, use Y square dt. And remember, you're defining it for one time period. That's the reason AC current has to be periodic. If it's not periodic, you can't define a DC equivalent. Next thing. Let's see some questions. So if you have a voltage V is equal to V naught sine omega t. Standard result, you should definitely remember this. Find VRMS and V average for any half cycle. Half cycle meaning half time period. Let's get this. You just have to put it in the function and integrate. For a sine function, what is the VRMS value? Get this, it's an easy one. Right, we have. Let's see. So VRMS will be root over integral V naught square sine square omega t dt 0 to t integral dt 0 to t. So how do you integrate a sine square function? Sine square omega t 0 to t. Remember, t is nothing but 2 pi by omega. Sine square omega t is can be written as root over 1 minus cos 2 omega t by 2. So when you integrate this, you will end up with 0 to t there. That cos 2 omega t ka term will be 0. This will turn out to be t by 2. So in one time period, cos function will be 0. So this will come out to be root over v naught square t by 2 by t. This will be v naught by root 2. That means whenever you get a sine function, you can replace that with a DC battery of voltage v naught by root 2. RMS is defined for one time period, everyone. 0 to t, and t is 2 pi by omega. Clear with that? See where it went wrong. So when you integrate that cos 2 omega t, you'll get sine 2 omega t. When you put t is 2 pi by omega, you'll get sine 4 pi and sine 0. Both are 0. So that second term will become 0. Clear? I'll leave that integration to you. That much you can handle. Now, the best thing about this, it's not only about this function. If you take v is equal to v naught sine omega t plus 5. So for any type of sine function, this v naught is called peak value. That is the maximum value of the voltage. So this is called the peak value, and this is how VRMS is defined as. So VRMS is defined as peak value by root 2 for sine functions. So this is V naught by root 2. Now that means in the house now, which we get the household supply, you ask them what is the voltage, people say 220 volts. So, but you say it's an AC current. How can AC current be constant like this? So then when you say 220, what are you exactly talking about? So when someone says the supply is 220 volt, or in US they say 110 volts, what they're talking is, this is actually the RMS value. They're talking that your house ka power supply is equal to a 220 volt DC battery. And this is your frequency, 50 hertz. That means omega will be 2 pi f or 100 pi. So the power which you're getting in the house is actually, the voltage is 220 root 2. That's your peak value. Sine omega t, omega is 100 pi t. So this is the power supply that you're getting in your house. And if you look at the peak value here, which is 220 root 2, this comes to around 311 volts. That means in your house, the voltage is fluctuating between minus 311 to plus 311. So the highest peak voltage in your house is 311 volts. It's not 220. This is the power supply that we are getting in the house right now. Is that clear, everyone? But we simply say house ka supply is 220 volt. So what you're actually telling is the DC equivalent, which is RMS value of your power supply. So if you have a bulb in the house, if you put this AC voltage and if you put a DC battery 220 volt, you'll get the same brightness. Clear with the RMS thing? Question is still not over. The second part. Right, Vihan, you got the second part. But there is a small catch. If you read the question, I said for any half cycle. So that does something. So how do you find the V average? V average is integral V dt by dt. You said for half cycle, so this will be 0 to t by 2, 0 to t by 2. This will be V naught sine omega t dt 0 to t by 2 by t by 2. And this will be V naught minus 1 by omega cos omega t. Limits will go from 0 to t by 2. This will be minus 2 V naught by omega t cos omega t by 2 minus cos 0. Remember, the time period is given by 2 pi by omega. So when you substitute here, this will be minus 2v naught. Omega t is nothing but 2 pi. And cos omega t by 2 will be cos pi minus cos 0. That will become minus 2. 2 will cancel. You get 2v naught by pi. This is your average value. But there is a problem. The word here is for any half cycle. That means Suppose if you take the first half of the cycle, that is from 0 to t by 2, the average would be 2v naught by pi. But when you said any half cycle, I could have taken a situation where half of it will be positive cycle, half of it will be negative cycle. In this case, the V average is 0. Or I could have taken the entire negative cycle, then the V average will be minus 2v naught by pi. So in one full cycle, it will be always 0. But the moment you said half cycle and you didn't tell me which time interval, I have a problem. That means your average value can lie anywhere between 2v naught by pi to minus 2v naught by pi. Is that clear, everyone? So that's the problem with the word any half cycle. Clear? Next one. Like you see, it's all math. Like if you have the integral, you put it there and you're done. I is equal to a plus b sine omega t. That sign is only with b. Find IRMS. All these are standard questions, right? Mains and bits CAT. Straightforward questions. I think this was a mains PYQ. They said 3 plus 4 sine omega t, find IRMS. Let's get this. You just have to put in that integral and integrate it. So IRMS will be root over integral a plus sine omega t whole square dt from 0 to t. Denominator will be t anyways. If you expand this, right, we have this will be integral a square dt plus integral b square sine square omega t plus integral 2ab sine omega t 0 to t, 0 to t, and 0 to t. Now, if you have a little idea, if you integrate sine square ka average will be half, and sine ka average will be 0. Hope you remember that. Average value of a sine square function is half, and average value of a sine function is 0 for one time period. So you can prove it with integration. So this guy will become simply a square t plus b square t by 2 by t. There we get a pretty good result, a square plus b square by 2. Remember, it is not overall by 2. Only b square will get by 2. So this is a constant plus a sine function. Important result, definitely remember this. You can always derive, but yeah, clear with this. Like I said, more of a max. There is nothing, no concept, nothing. Just put there, integrate, you get your answer. Next one. I is equal to a sine omega t plus b sine omega t plus phi. What if you had two sine functions? The same question I can also ask you in SHM. X is equal to a sine omega t plus b sine omega t plus phi. Find amplitude. Remember phasors? Let's get this. So you should go back to the phasors, SHM, the page 33. If you have two functions, a sine omega t plus b sine omega t plus phi, you can treat the amplitude as a vector and the phase angle as the base angle. So a sine omega t, zero angle, so you can treat it as a, and b sine omega t plus phi at an angle phi. Treat them like vectors, resolve, finish it off. So for page 33, SHM phasors. So the best thing is you can do this even if I give you 10 functions. So we can treat this thing as amplitude A because the phase angle is 0. This is B, this is phase angle phi. Then you can treat this thing as A plus B cos phi. This is B sin phi. So the resultant will be R making an angle alpha. So R will be root over A square plus B square plus 2AB cos phi. Parallelogram of vectors, you can do that. And tan alpha will be opposite side by adjacent side, B sin phi by A plus B cos phi. That means you can write this total current I is equal to resultant is R sine omega t plus alpha. That's how you can combine the two functions into this. But remember, this is your peak value. Therefore, IRMS will be R by root 2. Check. There I can ask you the same question in terms of amplitude in SHM. So if I give you sine functions, this is what you do. So remember, the previous one was a constant plus a sine function. This is a sine function plus a sine function. Both are different. All clear with this? Turning the page. Any doubts? V naught minus V naught t by 4, t by 2, 3t by 4, and t. Find VRMS. Triangular function. This is also pretty good mains level question. Let's give it a try. Now, one way to do is you can take the whole function from 0 to t and integrate and all. But if you see there's a symmetry, you can take advantage of it. So end of the day, you want to find the area under v square t, isn't it? So if I make v square, this guy will look approximately something like this. Okay. So if this was t by 4, this was t. This is 3t by 4 and t by 2. So see, this is what I was thinking. I'll find the area from 0 to t by 4 and I'll multiply into 4. Isn't that the area from 0 to t then? So integral v square dt from 0 to t is equal to 4 times integral v square dt from 0 to t by 4. Do you agree with that? Now, why am I so interested on 0 to t by 4? Because it is easy to find the equation of that line. From 0 to t by 4, it's a line passing through the origin. Y is equal to mx. So this looks like V is equal to voltage and the slope will be V naught by t by 4. So the equation of the straight line will be 4 V naught by t into time. Isn't this the equation of the straight line from 0 to t? Or else what I have to do, I have to find from 0 to t by 4, t by 4 to 3t by 4, and again this. I have to get 3 equations and then integrate. I will get it, but it becomes lengthy. Since it is symmetrical, find from 0 to t by 4 and into do 4. Now can you do? Right, Niharika. So if you do integral v square dt from 0 to t by 4, this will be 16 v naught square by t square. This will become t square dt. You get v naught square t by 12. So this thing turns out to be v naught square t by 3. So then we are done. This will be v naught square. V naught by root 3. And the best thing about this triangle function, right? Definitely remember this. Quite a good result. The best thing, it doesn't matter what kind of triangle you take. You can take a triangle which is not symmetrical. Like it's periodic, but if you see the triangle, right, this is ending at t by 3 and this is t by 2. Just make sure the peak values are same. You can have a triangle like this. So all triangle functions will have same. PRMS. Just make sure this is V naught and this is minus V naught. Clear with that? You can check it out and see. You can take some random function and try it and see. You will get the same. Clear? These four are the standard models. Normally at a mains and bits level, this is the things they will ask you. Now, if they really want to do something more, you can make up something of this sort. What if I give you a function like this? Let's say we have a current here flowing for I1. Time is t by 3. Then the current is minus I2 for another time t. Again, it repeats. Find IRMS for this. What if you create a Frankenstein monster like this? Sine function, a triangle function, a straight line, and again a triangle function, and again it repeats. You made this of different pieces, where this time is t by 4, this is t by 2, this is 3t by 4, and this is t. Let's say this is v naught minus v naught. Find VRMS. And IRMS. How do you handle these things? Hmm. Looks right, Vihan. Looks right. How do you handle this, right, Poroja? Again, go back to the whole story of RMS. Don't get too much stuck into that mathematical equation. What is RMS? The heat produced must be same. So if that was the thing, instead of finding all the functions which we are doing, let's find the heat only. So let's say if you send this current through a resistor R, what is the heat produced? So heat and now see, even though I1, I2 are changing, right? They're still constant for that given time interval. So this will be I1 square R for a time of t/3. This is the heat produced. This will be I2 square R for a time of 2t/3. And now you are saying you want to replace it with a single current IRMS square into R per t. Isn't that the whole concept of RMS? There. So IRMS will be root over I1 square plus 2I2 square by 3. Is that making sense? Now can you do this, the B part? How do you handle this? Let's see. See, again, the same idea. End of the day, the RMS is I want to replace the DC battery. So why don't I just replace this sine function with a DC thing? So what is sine ka RMS value? V0 by root 2. So replace a voltage of V0 by root 2 for time t/4. Because end of that, if you're only interested about heat produced, why do I care what is the function? For a triangle function, what is the RMS value? V0 by minus root 3. So you can assume there's another battery for V0 by root 3. Then another battery for minus V0. Then another battery for V0 by root 3. Are you getting this? So you can replace each function with respect to RMS values because they're going to produce the same heat. So then the heat produced will be V0 by root 2 whole square by R times t/4. V0 by root 3 whole square by R times t/4. V0 square by R times t/4. And you're saying you want to equate this to VRMS square by R. T cancels, R cancels, V0 square comes out. You end up with 1 by 2 plus 1 by 3 plus 1 plus 1 by 3. That would be 3 by 2 plus 2 by 3. 9 plus 2, 11, 11 by 6. 3, 9 plus 4, 13 actually. 13 by 24 root V0. Check. There, that's what you can do. You can replace them with their individual RMS values. Now you have made them DC batteries. and then get the RMS of that, because end of the day heat produced is same. Clear, everyone? Any doubts on this? Next thing. Yeah, that's one thing about AC and DC. Next thing, we have an AC voltmeter and an ammeter. So AC voltmeter and ammeter, they measure RMS values. So when you take a voltmeter and put it in your house ka supply, you don't get that function which is changing with time. What you see is a constant number. Then what is it measuring actually? It is measuring the RMS value. So these instruments, they work on based on the heat produced. Therefore, these are called hot wire instruments. Similarly, if you take a DC voltmeter or ammeter, they measure the average value. So let's say you take two supplies, 220 volt AC, and you take 220 volt DC. And you connect this to an AC voltmeter, and you bring a DC voltmeter. So if you connect an AC voltmeter to 220 volt AC, 220 volt DC. If you connect a DC voltmeter to 220 volt AC and 220 volt DC, what do they show? What will be the readings? If you connect an AC voltmeter to DC, what will it show? If you connect DC to AC, what will it show? Try. I'll give you 30-40 seconds. Think for a minute. For 220 volt AC, what is RMS? This is the RMS 220 volt. For 220 volt DC, what is the RMS? Same value. This is only RMS. For a constant voltage, RMS value is the same. So AC voltmeter will show 220 because it measures RMS value. But what does DC show? DC will show 0. Why? An average of a sine function. So if you take a periodic function like this, the average value is 0. DC will show 220. Clear with this? So DC voltmeter will show average value. If you put it in a normal source, the sine function, the average value will be 0. So it will show 0. Clear? That's a little about AC voltmeter and DC voltmeters. Next thing, we also have a certain terminology. People use these words lagging and leading. Basically, this is regarding the phase difference. So for example, if you say voltage V is equal to V naught sine omega t, and if you say current I is equal to I naught sine omega t plus phi. So here omega t plus phi is ahead of omega t. This is the phase angle. So we say current is leading the voltage by phi. So current ka phase angle is 5 degrees more than the voltage. More of a terminology there. You can also say voltage is lagging the current by phi. Both are same. So this is one terminology, the use of phase angles. Yeah, this is one part of the AC circuits where they give you AC, DC, conversion, all that stuff. The next part, now we studied so far what happens if you keep a resistor, capacitor, and an inductor to a DC battery. We saw RC charging circuit, we saw LC, oscillations, we saw LR discharging circuits, charging circuits. All that is great. Now, what happens if you keep a resistor, inductor, and a capacitor to the AC source? So how do these things behave when you have a source which is changing with time? So generally, we study always the sine sources. That is our standard source which we stick. Now, before jumping into it, there is something we will do it in a little different way. The standard textbook method, I'm really not pro with that because at the mains level, that ठीक है, but if the problems become complex, things start going pretty haywire. So we are going to do a little differently. So listen carefully, not tough, but it'll be a little different. So basically, we're going to use phasors. So the phasors is actually a form of complex numbers. So let me show you that. So if I give you a complex number called Z, which is A plus JB. So here J is your imaginary number root minus 1. We are already using I for current, so we are using J here. Normally, remember your maximum complex number A plus IB. That I is root minus 1, but we use I for current, so I'm using J. This is your imaginary number. So what does Z actually mean? Let's start from there. When you say a complex number Z, frankly speaking, it is nothing but Cartesian coordinates. So you have a real number and an imaginary. So A on the real, B on the imaginary. This was your Z. This was your angle phi. So here the magnitude of Z is simply root over A square plus B square, and the angle tan phi is nothing but B by A. So if you think about it, you are nothing but that Z and phi are simply polar coordinates. So this is how we write the phasor form. If I put Z bar, remember I'm putting Z vector form, it is not a conjugate. Z bar wo conjugate nahi, it's Z bar. The moment you write put Z bar on the top, meaning we are writing a phasor form. So a complex number, when you convert into phasor form, you write this thing as mod Z angle phi. Matlab you write this thing as root over A square plus B square angle phi. So you can convert a complex number into the distance and the angle. Let me show you with an example. If I say Z is equal to 1 plus J. So this can be written as, what is the magnitude? 1 plus J ka magnitude is root 2, and the angle it makes is 45 degrees. Suppose if you say Z is equal to 10 plus 10 root 3J. Then Z bar, the phasor form, the magnitude is 20, and the angle it makes is 60 degrees. Are you getting what we're doing? Basically, if you see, this is your X coordinate, this is your Y coordinate, this is your radius, and this is your theta. So phasor form is nothing but you're converting into polar coordinates. So this gives you the magnitude. So a phasor form has two things, the magnitude of the vector and the angle it makes. So writing a complex number in this form, we call it phasor form. In maths, you must have studied something like this, cis theta, something of that sort. So instead of writing that angle, I'm just putting the angle outside, magnitude and an angle. The angles are always measured from the real axis as a reference. Is this making sense? So if I give you a complex number, you can write it as magnitude into angle. Clear with this? This is something new. We are making it up. Similarly, you can do the same thing with sine and cos functions, which you have done before. So if you give me v is equal to v naught sine omega t plus phi, this also I can write in phasor form v bar. So the moment I put v bar, see voltage bar doesn't make sense, right? It means it's a phasor form. This will be v naught into angle phi. Basically, this is your amplitude. Isn't that what we do in phasors? You take the amplitude as a vector and phi is your angle. So not only complex numbers, you can even convert your sine functions into phasor form. Example, if I give you v is equal to 2 sine omega t plus 30 degrees. So the phasor form of this is 2, 30 degrees. If you say I is equal to 10 sine omega t minus 37 degrees, the phasor form of current will be 10 minus 37 degrees. You can just put the angle inside. And remember, we need to keep everything in sine ka form. If you give me something like 3 cos omega t, I'll write this thing as 3 sine omega t plus 90. So the phasor form V bar will be 390 degrees. This is the first step that we need to know. If I give you a complex number, you can convert into a phasor form. Phasor form is simply magnitude into angle. If I give you a sine function, I can convert that also into a phasor form. So phasor form is simply the magnitude and the phase angle. Is this making sense, everyone? This is the first thing that we need to do. And you will see why we'll need this. Once you convert everything into phasor form, you can start using your Ohm's law, V is equal to IR. Things will become similar to DC circuits. The story is always the same. We are so obsessed with DC circuits, you want to bring everything into DC form. Like I said, it'll be a little confusing for the first 10-15 minutes, but after that, once you get the hang of it, you will see problems will just keep coming off. Chapter becomes quite easy. Any doubt so far? Take a break, come back by 9:40. We'll continue from here. Any doubt so far? Chalo, come back in 5 minutes. Chalo, let's start off. Yeah, that's a little bit about phasors. Now, how do phasor operations work? So if you say Z1 bar, whose magnitude is Z1, theta 1, Z2 bar is Z2, theta 2. So if you multiply phasor Z1 bar or Z2 bar, it is simply Z1, Z2, just add up the angles. It's just like cis theta 1 into cis theta 2. Cis theta 1 plus 2. If you divide the phasors, that will be Z1 by Z2. Phase angle will be theta 1 minus theta 2. So addition and subtraction, multiplication and division are easy. Addition is a little pain. So Z1 bar plus Z2 bar will be R into angle alpha. So basically we have to add them like phasors. So this is a reference. The Z1 is making an angle theta. Z2 is making an angle theta 2. This angle will be theta 2 minus theta 1. So you can resolve this into components. Z1 cos theta 1, Z2 cos theta 2. Then you get the resultant R here, then you get alpha here, and you can solve. Or simply you can also get R from, parallelogram of vectors, which is Z1 square plus Z2 square plus 2Z1 Z2 cos phi, cos theta 2 minus theta 1. Clear with this? So when you add them, this is what you do. Subtraction, multiplication and division are easy. Addition and subtraction are a little painful. Clear with this? So now you know how to write a phasor again. If you get a complex number, you can write a phasor like this, magnitude into angle. If I give you a sine function, that also I can write as a phasor, amplitude into angle. And this is what you do when you multiply, divide, and add. All clear with this? Now let's see how these things pop up. So let's say if you take a resistor in an AC source. So when you take a resistor and put an AC source, we are going to use standard sine functions only normally. E is equal to V naught sine omega t. Let the current be I. Remember, your Kirchhoff's law is always valid. V naught sine omega t minus IR is equal to 0. So we get I is equal to V naught by R sine omega t. So if you look at this kind of looks normal. Matlab, yeah, it kind of behaves like DC only. It doesn't look big of a difference. Both are sine, everything is in phase. So if you try to write this in phasor, this will be V naught angle 0 degrees. If you write the current in phasor form, this will be V naught by R 0 degrees. You can clearly see both are in phase. Voltage and current are in phase. What do you mean by in phase? When current goes to maximum, voltage also goes to maximum, and vice versa. When voltage goes to minimum, current goes to minimum. So here actually there's not much of a phasor thing. Voltage and current both are in phase. So basically a resistor in AC circuits will behave like a resistor only. Matlab, you will see what it means. So a resistance really doesn't do much. It behaves like a standard stuff. It is straightforward. Things will get messed up when you keep an inductor and capacitor. Let's see from there. Clear with this. So if you keep a resistor, it behaves like a resistor. There is no problem. But what happens when you keep an inductor? Again, remember, the whole thing is we are obsessed with Ohm's law. We want to bring everything in the types of V is equal to IR. Inductor with an AC circuit. So if you have an inductor, V naught sine omega t. Minus L di by dt is equal to 0. If you integrate this, you end up with V naught by omega L minus cos omega t. This can be written as V naught by omega L sine, that will be 90 minus, so that will become omega t minus 90 degrees. So look at this function. Now forget about all that. If you just see this function here, you will notice something. Since we are so obsessed with writing I is equal to V by R, this thing kind of looks like V by R. So current is equal to voltage by resistance. Great. That means I can say resistance is looking like omega L, isn't it? So if I replace an inductor with omega L, my problem is solved. But there is an issue. Magnitude ka problem to solve ho gaya, but you created this extra minus 90 degrees. The sine function became sine omega t minus 90. Look at the resistance. Sine omega t remained sine omega t. So I didn't have any problem. But here the problem is the sine omega t became sine omega t plus 90. So then people started thinking, okay, is there any mathematical function, right, which can help me with these angles? Magnitude to aage omega L. Now, is there anything in max which can give you something about rotation and 90 degrees? When you think in that perspective, complex numbers, right? What is the meaning of a complex number multiplication? Think about it. If you take a number 2 and if you multiply with I or J, whatever you want to call, isn't it rotation of 90 degrees? Whenever you multiply a complex number, what you're doing is indirectly you're rotating the complex number, rotating the vector. For example, say, let's say Z is 1 plus J. If you rotate with J, this will become J plus J square. This will become minus 1 plus J. That means this vector, which is 1 plus J is here, it becomes minus 1 plus J, means it has rotated by 90 degrees, isn't it? A complex number multiplication is nothing but a rotation. So when you multiply with plus J, you will rotating by plus 90. When you rotate minus J, you're rotating with minus 90. If I multiply with 1 plus J, then what is the phase angle? Root 2 into 45 degrees means you're increasing the magnitude by root 2 and you're rotating it by 45 degrees. It's making sense now? So a complex number multiplication is nothing but rotating the vector. So then we thought, okay, so if I use a complex number, I can make this into a vector. So So what is the voltage ka phasor form? So V bar will be V naught 0 degrees. So current ka phasor form I will be V naught by omega L minus 90 degrees. And like I said, we are obsessed about Ohm's law. So I will not call resistance, I'll call it XL bar will be V bar by I bar. Since we're already using for resistance, we use a new symbol called reactance. L means inductance. So it's a reactance for inductor. Now, can you see, doesn't this look like Ohm's law? R is equal to V by I. So when you divide this, you'll get V naught angle 0 degrees by V naught by omega L minus 90 degrees. So we get omega L 90 degrees. That means if you look at this inductor, XL bar is omega L 90 degrees. If you convert this into complex number, this will become J omega L, isn't it? There is no real number. That means you can replace an inductor with a resistor, a complex resistor, which is J omega L. Again, remember the meaning of J omega L. It is just a mathematical manipulation. J omega L will take care of the magnitude, J will take care of the phase angle. You're getting it? We will see some examples, you'll get the hang of it. So this complex number takes care of phase angle. So we are actually using complex numbers in order to create these phase angles. You need to understand that is what you do in maths. Tomorrow when you're writing something in coding and everything and you want to study traffic on a road using your AI, how do you train your AI to study traffic on a road? You use matrices. You use a three-dimensional matrices. Each column will give you value. If you want to solve a circuit, current electricity, you use matrices. So if you are planning to learn coding, you should be really good at least, major maths concepts. Clear with this? So basically you can replace an inductor. We'll call this XL as J omega L. We don't call it resistance because R is already there. We call it reactance. So if you try to look at the voltage, so here the current is lagging the voltage, meaning when this is maximum, this is 0. This is maximum, this is 0, and so on. Voltage leads the current by 90 degrees. That means if voltage VL is this way, your current is 90 degrees behind. Remember, we take anti-clockwise as positive, right-hand thumb rule. So if VL is upward, you can rotate the same thing by 90 degrees if you make it current. There. So voltage will be always 90 degrees ahead of current. Let me show you how they'll frame questions. Example, let's say we have an inductor. Let's say current I is equal to 2 sine omega t plus 30 degrees. And let's say inductance XL, which is omega L is equal to 10 ohms. They'll just give like this. They'll not give all that complex number and everything. That is something we created. So step one, when you solve these problems, what you do, convert everything into phasors. I bar will be 2 angle 30 degrees. So here this XL is actually a complex number J omega L. The moment you put XL bar means you have converted a complex number into a phasor. Omega L and J means 90 degrees. Are you getting how I'm getting 90? Real number is 0 there. You got everything into phasors. What do you want to find? Voltage. So voltage across the inductor is equal to current into reactance. V is equal to IR. There, that is the thing. Once you convert everything into phasors, your Ohm's law comes back. You can't do Ohm's law on sine functions. You can't do Ohm's law on complex numbers. But once you create a phasor, you get everything. So this will be 2 into 30. Omega L was 10 into 90. So this will become 20, 120 degrees. So bring it back, VL as function of time t. That will become 20 sine omega t plus 2 pi by 3. So when this current goes through an inductor, this is the voltage across the inductor as function of time t. Are you getting what we did? Convert everything into phasors, do all the operations in phasors, and bring it back to the sine function again. So you can use Ohm's law only when everything is in phasor form. That is the main theme of the story. Is this clear, everyone? Let's see one more example. You guys try this. So we have an inductor, L is equal to 10 millihenry. I is equal to 20 sine 1000 t plus pi by 3. Can you find the voltage across the inductor? Find VL as function of time t. Remember sine omega t, this guy is 1000. So 1000 omega is 1000. Let's see. Step 1, let's create everything in this thing. What is XL? XL will be J omega L. So that is J is a complex number, omega is 1000, and L will be 10 into 10 power minus 3. That will become 10J. So the phasor form XL bar will be 10 into 90 degrees. Current ka phasor form will be 20 into 60 degrees. Voltage VL bar is equal to current into resistance. We don't call it resistance, reactance. That will be 200, 150 degrees. So VL as function of time t will be 200 sine omega t plus 5 pi by 6. Easy. Finding things in function of time t is one of the most complex things. There is a regular way of doing using all phasors and all. We'll see that later on. There's a standard method. But this is more superior. Once you get everything in terms of time t, you can get whatever you want. Clear? Let's see one more. Now you guys try. Let's make it a little more complex. What if you have a resistor and an inductor? Let's say resistance is 10 ohms. XL is 10 root 3 ohms. Now remember, in all the questions, they'll never mention complex numbers. It is something we did. They will say XL is 10 root 3. You need to understand inductor is J. This is current I. So I is equal to 2 sine omega t plus Pi by 3. On top of it, you also kept a voltmeter here. AC voltmeter. There. So find VR as function of time t. Find VL. Wait, let me do something here. VL as function of time t. Let's put two voltmeters. V1, V2, V3. Find reading of the voltmeters V1, V2, V3. First find VRT and VLT. We'll talk about the voltmeters. Let's see how will you handle this. Let me show you. See, let's forget about the voltmeters for a moment. First of all, resistance is what? R bar is 10 into 0. So you convert into resistance also into phasors. What is XL bar? XL bar is 10 root 3 J, which is 10 root 3, 90 degrees. What is I bar? 2 into 60 degrees. There, we got already. So you want VR as function of VR bar. What is VR bar? Current into R bar. You're getting it? Once you get this, it's all Ohm's law only. V is equal to IR. You just multiply. So that will be 2 into 10, 20, 60 degrees. So VR as function of time t will be 20 sine omega t plus 60 degrees. Now understand something. This is your peak value. What does a voltmeter measure? RMS value. So what is VRMS? 20 by root 2 or 10 root 2. This will be the reading of voltmeter 1. Is that making sense? So no need to do anything new. The answer is there only because voltmeters will measure RMS value. What you got is a function of sine. So what is RMS value? By root 2. Similarly, VL bar will be I bar dot XL bar, which will be 20 root 3, 150 degrees. So VL as function of time t will be 20 root 3 sine omega t plus 150. This is your peak value. So VRMS will be 20 root 3 by root 2. This is the reading of V2 voltmeter. So anytime they just ask you reading of the voltmeter, right? You need not convert everything. You got the peak value, no? This is the peak value. Directly you can do by root 2. Are you getting that? How do you find V3 car reading? So listen, for V3, what we do, same story. I still want to use Ohm's law. You're getting it? So you want the potential difference between these 2 points, A and B. So we will create a term called impedance. We are going to call that later on, but I'll write it for now. So I'll call it Z, which will be the equivalent resistance, basically 10 plus 10 root 3 J. You can add the resistors just like regular series and parallel. This is your equivalent resistance. There's a name for this. We call it impedance. So this is the equivalent resistance between ZAB. Convert this into phasor. So what is the resistance between AB? 10 and 10 root 3, 20 magnitude, angle 60 degrees. So what do you want to find? Voltage across AB. So VAB bar will be current into ZAB bar. Ohm's law. That will be 2 into 20, 40, angle 120 degrees. Are you getting what we're doing? If you want voltage across A and B, find the resistance across A and B in complex form and get that into phasor and just multiply into R. You want RMS value, right? Actually, question got over. This is your peak value. Therefore, RMS value will be 40 by root 2. This will be the reading of V3. You didn't ask me as function of time t. You want, we can get that also. So the voltage across A and B as function of time t will be 40 sine omega t plus 2 pi by 3. You can literally find voltage across anything as function of time t. Is this making sense? You can just add up numbers like complex numbers. You're adding 10 plus 10 root 3j. It is 10 plus 10 root 3j. That's it. You can just add them up series, parallel, everything works. Wheatstone bridge also works. You'll see that later on. I think if you understood this, it can be a little confusing, but I hope everyone understood at least 80-90%. There might be a little here and there. If you got this, I think you can handle most of the problems in this. But let's see one more. Clear what we did? Let's say we have a resistor, we have an inductor. Let's say resistance is 30 ohms. XL is 40 ohms. Connected to a battery. V is equal to 100 sine omega t. And let's say you connected a voltmeter across this V1, V2 across this. And this is the current. Find the current as function of time t. VR as function of time t. VL as function of time t. And reading of the voltmeters. That is a story every time. Get the resistance in complex form, convert that into phasor. Get the convert voltage into phasor. Ohm's law. You want I is equal to V by R. Just think we don't call it resistance anymore. We call it impedance. Impedance is a combination of resistance and reactance. So R is resistance. For inductors and capacitors, we call it reactance. If you combine them, we call it impedance. So next time when you buy any electronic item, at the back now, observe that it will be written 34 ohms impedance. Because when devices use AC circuits, we don't call it resistance anymore. Anyway, if you look at the English meaning, they kind of look same. Resistance, you resist. Impedance, you impede. When kind of you're resisting only. I think that is right, Aditya. Get this. I'll give 2-3 minutes. Figure it out. Take your time, do it aram se. Then once I do it, you can check your answers. Previous page here. Meaning, in case by anyone confused, see, this is what I did. I converted both into resistors. This was 10 and this was 10 root 3j. Since both are in series, I added them. Clear? Go ahead. Let's get this. Try. 2 minutes, 2 to 3 minutes more. Take your time, do it properly, because I think if you got the hang of it, I think you will be handle many problems. We have almost 70-80% chapter in your hands. The next class, I'll teach you the standard stuff, what is there in the book, and then we can see. The right tan inverse 4/3 is, you know, the angle, God. 3753. God. Kuch bhi kar rahe ho. Why do you think I gave such good numbers? 30, 40. Karo. Right, I'll get some water and come. Let's see. Check your answers. Step 1. Let's convert everything into complex numbers. So your circuit becomes 30 and this becomes 40J. So your impedance, which is 30 plus 40J. The phasor form Z bar is 50. The angle is tan 30, 4/3, which is 53 degrees. Voltage ka phasor form V bar is 100, 0 degrees. You want to find current, you'll get phasor form ka current. I bar is nothing but voltage by impedance. When I put a bar, it is still this thing. So this will be 100, 0 degrees by 50, 53 degrees. Check karo re Aditya, 37 hai na tujhe? This will be 2 minus 53 degrees. That means the current as function of time t is 2 sine omega t minus 53 degrees. That's your current as function of time t. What do you want to find? Voltage across the resistor. So VR bar will be I bar dot R bar. Remember, if you want to use Ohm's law, it should be in phasor form. You can't use omega t and all this thing in phasor form. I bar is 2 into 53. R is 30 into 0. Therefore, this guy will be 60 minus 53 degrees. So VR as function of time t will be 60 sine omega t minus 53. So RMS value will be 60 by root 2. This is the reading of V1. Next thing, you want to find VL bar. VL bar is current into XL bar. So for inductance, we call it XL. So that will be 2 into 53. XL will be how much? XL bar will be 40 into 90 degrees. Then multiply. This guy will be 80, 37 degrees. So VL as function of time t will be 80 sine omega t plus 37. The voltmeter will read always RMS value. So RMS value of this will be 80 by root 2. This will be the reading of V2. Is this clear, everyone? Please check your steps, what we did. Anyone not convinced with anything, got confused anywhere, please ask. Definitely after today's class, check it out. Each and every problem, check it out. You still get confused, ask me in the next class, but get it cleared. Because these things you'll not find in any books also. This thing normally they teach you in IIT third or fourth semester. So that I modified a bit. Clear with this? What happens if you bring a capacitor now? Capacitor in an AC circuit. We know the charge on the capacitance will be Q is equal to CV. So this will be CV naught sine omega t. Current I will be dq by dt. This will be C omega V naught cos omega t. That means you can write current E is equal to V naught by 1 by omega C sine omega t plus 90. Again, same idea. If you see, it looks like V by R, but you're getting a phase angle there. Therefore, I bar is nothing but V naught omega C 90 degrees. V bar is nothing but V naught 0 degrees. So we define something called XC bar. Just like inductor has XL, this is XC. Just to differentiate, boss, this belongs to a capacitor. This is called reactance of capacitor. So there, for resistors, we call it R. For inductor and capacitors, we call it reactance. And if you're taking a combination of them, we call it impedance. This will be V bar by I bar. This will be V naught 0 degrees by V naught omega C 90 degrees. We get omega C minus 90 degrees. That means an inductance XC can be written as, what is minus 90? Minus J, na? This is 1 by omega C. Minus J by omega C. So plus J indicates plus 90, minus J is this thing. That means if you have a capacitor, you can replace this with a resistance. Minus J by omega C, a complex resistance. And you can clearly see here, current leads the voltage by 90. If this is voltage, this is current. So current ka value will be higher. So if this is voltage, current should be ahead by this thing. So current will be 90 degrees ahead. If you rotate the current horizontally, then the voltage will be down. Clear with this? Same story. Whatever you do with the inductor, you can do the same thing with capacitor, only the formula is a little different. Let me show you an example. Same story. Let's say we have a capacitor. C is equal to 100 microfarad. This is I. I is equal to 10 sine omega t plus pi by 3. And let's say omega is 100. Find voltage across the capacitor. Get this. Find the voltage across the capacitor. Let's see. Same thing. Let's convert this into a resistor. Minus J by omega C. So this is minus J. Omega is 100. C will be 100, 10 power minus 6. That is minus 100 J. So phasor form XC bar will be 100 minus meaning minus 90 degrees. Remember, it is magnitude. Don't put minus 100 into 90. It is 100 minus J. Minus J is minus 90 degrees. It's always magnitude into the angle. I bar is 10, angle 60 degrees. You're done. What do you want to find? VC bar. So VC bar is current into reactance. So that will be 1000 minus 30 degrees. Therefore, VC as function of time t, 1000 sine omega t minus 30. Clear? Any doubts on this? Let's see one question. I think if you got this, you got the hang of everything. Let's say we have a capacitor, we have a resistor, we have an inductor. We brought everyone. We have an AC source. Let's say this guy is XC, which is 20 ohms. R is 10 ohms. XL is also 10 ohms. Voltage V is equal to 10 sine omega t. You kept a voltmeter V1 across these two guys. And you kept a voltmeter V2 across these two guys. Find current in the circuit. Find I of t, VR of t, VL of t, VC of t, reading of the voltmeters. Yeah, this would be an advanced question. If I just ask you reading of voltmeters, that can be done normally. There are ways, but the moment I ask you as function of time t, these are advanced questions. Mains में generally I have not seen them asking in terms of time t. Generally, they'll mostly stick to the RMS values and the readings of voltmeters. Finish off. Last one for the day. It'll take time though. It just makes you happy. Oh, last one, guy. The first four are easy. Those things you can handle easily. The reading of voltmeters, little work is involved. Let's get this. Aditya, that looks right. Randomly omega it looks like. ले लेना 100T or something. ठीक है. The thing is, once I give XC, XL values, now omegas are already included in that. So it really won't matter what is omega. Now, if I give in terms of capacitance as Farad, inductance as Henry, then you need omega. Oh, इसके लिए पूछ रहा था क्या? You thought you were going to use omega? No, you don't need omega. I already gave XC and XL. Omegas are included. Right, Niharika. You got the current right. Reading of V1 is 10. I don't remember the answer, but इतना अच्छा number तो नहीं है. 5√5. I don't know. I don't remember much. Let's see. I'll show you the first 4 parts. Others can keep trying V1, V2. I hope everyone has done the first 4. वो तो हो जाना चाहिए. Anyway, let's see. So let's remove this voltmeter for a moment. So if I write this in terms of resistance, this guy is minus 20J, this guy is 10, and this guy is 10J. XL, R, and this is XC. So what is the impedance? 10 minus 10J. So what is Z bar? 10√2 minus 45 degrees. What is V bar? 10, 0 degrees. So what is current? V bar by Z bar, which will be 1 by √2, 45 degrees. So current as function of time t will be 1 by √2 sine omega t plus 45. There, that's your current as function of time t. Then, next thing. So we got current I bar is equal to 1 by √2, 45 degrees. What is XC bar? XC bar is 20 minus 90 degrees. What is R bar? 10, 0 degrees. What is XL bar? 10, 90 degrees. You got everything. What do you want to find? VR bar? So VR bar is I into R bar. That is 10 by √2, 45 degrees. So VR as function of time t will be 5√2 sine omega t plus 45. Next thing, VL bar will be I bar dot XL bar. That would be 1 by √2. Again, same thing, you'll get 5√2. This will be sine omega t. $135. Therefore, VL as function of time t will be 5√2 sine omega t plus 3 pi by 4. VC bar is I bar dot XC bar. This would be 10√2 minus 45. The VC as function of time t will be 10√2 sine omega t minus 45. Got all this? Convert into phasors, get the current, just keep multiplying. It's tiring, but you get everything. Clear? Any doubts on this page? Then the next part. So now you want between the voltmeter. So you want between this point A and let's call this point B. You're connecting the voltmeter between these two guys. So you're interested in the resistance between ZAB. So what is ZAB? ZAB will be 10 minus 20J. So what is the phasor form of ZAB? 10 and 20 ka magnitude will be √500. So that's 10√5. Phase angle will be phi, where tan phi will be minus 2. Clear? And then you're done. So you want VAB bar, right? So VAB bar will be I bar into ZAB bar. Just like Ohm's law, find the equivalent resistance and multiply. This will be 10 root 5 by root 2, and the phase angle will be 45 plus 5. Anyway, I'm not interested in the phase angle. Why? This is the peak value, isn't it? What will the voltmeter measure? RMS value. So RMS value will be 10 root 5 by root 2 by 1 by root 2, which turns out to be 5 root 5. This is what V1 will measure. Is that making sense? Got the idea what we did? So just if you want between A and B, get the resistance between A and B, convert that into phasor form and multiply into current. You want as function of time t, I can get that also, but voltmeters don't care anyway. They just want RMS value. Clear with this? Same thing I can do for the other guy. This time you want between this point, let's call it C and let's call it D. So this time you're finding between ZCD. This will be 10 plus 10J. This number looks good. So phasor angle will be 10 root 2, 45 degrees. So VCD will be multiply both of them, you get 10, 90 degrees. This is your peak value. So RMS will be 10 by root 2. This is the reading of V2. Any doubts on this? Definitely try all these things again. Just spend another 10-15 minutes and make sure to do all of them once more. Helps a lot. That's it. Because I know you understood, but examiner, if you don't do it again once more, plus becomes minus, that J becomes something else. Everything will start looking like big mess up. Because what we did is complex number phasor. There is a lot of mix up there. Clear with this? So do check it out. So do these things again. So next class when we catch up, we'll continue from here. We're going to see the standard models, how normally they do it in the book and all. We will see that also a few problems. And then we'll do more problems on this. So technically there's not much. I think another little bit of theory is there. But the major thing that I wanted, you guys are in. Matlab, you guys got it. You'll be able to handle a lot. Then, okay. And after that, we'll Monday, I think by next Friday, we'll wrap up the chapter. AC will be done. It's a very small chapter. Even in HC, we have 24 questions. So I'll send you a sheet also. So it's pretty easy to solve once you understood what we did today. And after that, we'll start off with waves. Okay. With that, we'll wrap up for the day. I think this week a test, right? I'll post the results tomorrow. There is a delay. And you'll get a new paper online tomorrow. Okay. With that, we'll wrap up for the day. So any doubts, anything, please stay back and ask. Also free to leave. And do remember, EMI is still pending. Do finish off by next week.